Welcome to Ask and Learn.
Okay, so for this exercise, we need to determine how many positive integers are between 100 and 999. Okay, so how many of those integers are divisible by 7? So a way to do this is first notice that this 100 here is equal to multiply 14 times 7 plus 2. Okay, and this defines a lower bound. And similarly, the 999 is equal to 142 times 7 plus 5. And this is a upper bound for the interval and is inclusive. Okay, so you can see that here we have 14 times 7 and here 142 times 7. So you can see that the numbers between 14, so I'm going to change here the colors, so between 14 and 142, those integers, for example 15 times 7, it's going to be contained in this interval here, but even more is divisible by 7. So these numbers here, by doing this kind of decomposition of the number, it's going to tell us how many numbers are divisible by 7 on this interval. And you can see that those numbers, I'm going to put here the number of integers divisible by 7 on that interval, are going to be 142 minus 14. Okay, it could be if we consider this number, you can see if 14 times 7 is included, then we need to add here a plus 1. But in this case, it's not considered because the lower bound is defined by 14 times 7 plus 2. So this is less than this number and is not going to be on that interval. So in this case, it's just 142 minus 14. And that is equal to 128. Another way, and sometimes it's preferable to do it that way, is to consider the floor function. So you need to consider the floor function of 100 divided 7, and this is equals to 14. That is the number that we wanted. And in the similar way, 999 divided 7, the floor function of this is equals to 142, and we obtain immediately this number here. But I like to make this kind of decomposition of the numbers to visualize why the other numbers, like 15 times 7, are contained in this interval. And why the subtraction of these two numbers of 142 minus 14 give us the total number of integers that are divisible by 7 on that interval. Okay, so it's just for illustration, but the usual way is using these floor functions here. Okay, now we need to determine which of them are odd. So how many on that interval 100 999 are odd? So this is really easy. You just need to take you need to subtract, you need to take how many numbers are between these two, in this interval. So you can see that on that interval you have 199 minus 100 is equal, 999 minus 100, and this divided by 2. Why? Because half of the numbers are going to be odd and half of them are going to be even in this kind of intervals. But this is going to give you probably are not integer number, so you need to take the floor function again. And this is going to be equals to 450 are going to be odd. And the same are going to be even. Okay, and now we need to determine how many of them. Okay, so how many of them have the same three digits? Okay, so technically we have here three numbers, okay, that are going to be from 100 to 999. So here you can put the first number on this on this the first digit, to be more precise. It's going to lead the rest. Okay, if you, for example, here you put 1, then the rest is going to be 1. If you put 2 here, then the rest are going to be 2. So you need to focus only on the first digit, and you have how many possibilities on this first digit? You have from 1 to 9, so you have 9 possibilities here to put. The 0 is not admitted, it's not on the interval. You have 9 possibilities for the first digit, and that's going to lead the rest, so you have only 9 possible numbers with the same 3 digits. Okay. Okay, the next is we need to count now. So this is the letter D. How many of them, of the numbers between 100 and 999, are not divisible by 4? So how to proceed in this case? Well, first, we need to take the total number, the total numbers that are contained on this interval, and remember that the interval is inclusive. And we need to the total numbers on that interval minus the numbers that are divisible by 4. So n sub 4 are going to be the numbers, or the integers divisible by 4. That's the idea. The number, yes. How many integers on that interval are divisible by 4? That's the idea. So if we subtract this is going to result in the numbers that are not divisible by 4. Okay, just for notation here. So let's first calculate the total numbers that exist on this interval. So we have from 100 to 999, but remember that the interval is inclusive. Between 100 and 99, there is in total 999 minus 100 plus 1. Okay, and this one is because we are counting the 100s at the beginning. So this results into 900 possible numbers, possible integers to be more precisely. Okay, so we have in total, so t is going to be equals to 900. And now we need to calculate all the numbers that are divisible by 4. Okay, so the integers on the interval 100 999 that are divisible by 4. So in this case, we're going to proceed similarly as the first part of this exercise. So we take here 100 divided by 4 and the first function. But here you need to notice something. The 100 is already divisible by 4. Okay, so you need to take either you need to take another number here, one number less, so 999, and I'm going to explain this later. So you pick from 99 divided 4, and this is going to give you 24 here. and the upper bound will be 999 divided 4. The floor function of this is equals to 249. So then here the total number of there are 249 minus 24 integers between on that interval that are divisible by 4. So this is equals to 225. And now let me explain why I'm choosing here the 99. You can see that if we consider this, so 100 is equals to 25 times 4. Okay? And the 999 is equals to 249 times 4 plus 3. So in the previous example, when we choose the 100 that was divisible by 7, we have here 14 times 7 plus 2, and the last one was 999 was equals 142 times 7 plus 5. So when we choose here, in this case, when we check those numbers that were divisible by 7, in this case we start from 14 to 142, and we say that 142 minus 14 is equals to 128 possible integers divisible by 7 on this interval. In this case, we are not counting the 14 times 7 because this number is outside of the interval. But in this case, the 199, the 25 times 4 is on the interval. We need to count this number. So if we choose in the same manner as in the one that were divisible by 7, we need to take 249 minus 25, right? But we need to add here a plus 1 because that one consists in this number, the 25 times 4. In the previous case, we didn't consider that number because it was outside of the interval. But in this case, is inside on the interval because it's inclusive. So we need to put here this plus 1, and this equals to the number that you are obtaining here. Okay, the 225. But to make the things easier, when you see that you have that the number here that you're dividing here, 100 divided by 4, is contained on the floor function, you need to take here immediately the one number less, that is 99. Okay. Yeah. Okay. So that's the idea here. So that's why we consider the 99. Other way to see this is that, well, actually the floor function yeah, you need to take one less because otherwise you're going to have here a wrong number. Yes. Okay, so that's the idea why you take here 99, or in case that you choose here the 100 and the 100 is that number is divisible by the number that you're taking to, then you need to here add the plus 1, so you can work in the way that you feel more comfortable. But that's the idea. Okay, so we have the number of there are 225 integers that are divisible by 4 on that interval, but we want to know the number of how can I say it? How many numbers? Yes, how many numbers are integers, are not divisible by 4 on that interval. So I mentioned before that is the total numbers minus n to 4, and this equals to 900, that are all the possible integers on that interval, minus those that are divisible by 4, that is 225, that is the number that we just obtained here. And this equals to 675. Great. Now we need to calculate how many, okay, so how many integers are between 100 and 999 that are divisible by 3 or 4. So this is kind of hard. Well, it's not hard. Is you need to understand what is the meaning of 3 or 4. When you can divide by 3 or 4, that means, so I'm going to put that as n3 or 4, means the number, I mean, how many of those integers are divisible by 3 plus the numbers of the how many of those integers are divisible by 4, and we need to subtract the intersection of them. That means those integers that are divisible by 3 and 4. And the idea is this. So here you have your set, your big set of the interval. I'm going to call this interval I. Okay, so this is your set of the interval. Okay, just think it this way, because otherwise it's going to be complicated. So let's suppose that this part here is the set of numbers that are divisible by 3, and over here there is the set of numbers that are divisible by 4 on that interval. If you sum these two sets, you have this part, and the intersection here is counted twice. So because you're counting twice this part, you need to subtract the intersection, that is those numbers that are divisible by 3 and 4. Okay, so we have already this part here. We know that the number, the integers that are divisible by 4 are 675. Now we need to count how many of them are divisible by 3, and then how many of them are divisible by 3 and 4, the intersection. So the numbers divisible by 3. So we need to repeat the procedures as before. So here we take 999 divided by 3. In this case, this is going to return as 333. For the lower bound, we have 100 divided 3. In this case, you can see that 100 is equals to 33 times 3 plus 1. Okay, so in this case, it's okay to consider here the 100, not like in the previous case where we need to consider the 99. So this is equals to 33. So the total number, so n sub 3, the total number of integers between on that interval that are divisible by 3, it's going to be 300. Okay, and now we need to calculate the intersection. That means those numbers that are divisible by 3 and 4. So when you want to know which integers are divided by two numbers, that means that you need to find those numbers that are divisible by 12. That is the multiplication of 3 with 4. Okay, so in this case it's 12, and here we have the 999, and for the lower part we have the 99 divided 12. Okay, and this is equal sorry, I put directly this. Yeah. So minus, here is yes, so in this part here is 100 divided 12, the floor function. So this is 83 minus 8, and this is equals to 75. So 75 integers on that interval are divisible by 3 and 4. Okay, so we have all the numbers. Okay, so n sub 4, the numbers divisible by 4 are 675. For the set of the numbers divisible by 3 are 300, and the intersection, those that are divisible by 3 and 4 here, is equals to 75. So at the end, the number of integers that are divisible by 3 or 4, it's going to be n4 plus n3 minus n3 and 4 to eliminate the double counting here. So this is equals to 675 minus 75 plus 300. So here I got a mistake. The 675 was the numbers that are not divisible by 4, but we want those that are divisible by 4, and the number is 225. Okay, yeah, I'm really sorry for that mistake. 225, and this is equals to 450. Now, for the part F of this exercise, we need to count how many of them. So how many integers on the interval 100 and 999 are not divisible by either 3 or 4. So you may ask, what we are going to do now? Well, this is just a negation of the previous statement. So that means that these numbers that are not divisible by 3 or 4 is equals to the total number of integers on that interval minus the number of integers divisible by 3 or 4. So you can see that is much simpler. The total numbers was equals to 900 minus the number of those that are divisible by 3 or 4 we calculated previously is 450. So this equals to 450. Now we need to count for part G. So how many of them, so how many integers are divisible by 3 but not by 4? So that translates into taking the set of the numbers that are divisible by 3 and take the intersection, right? So this part is going to be those numbers that are divisible by 3 and 4. So we need to subtract n3 minus n3 and 4. So that will result in just the numbers that are divisible by 3 and not by 4. So so we just need to calculate this. So n3 minus n3 and 4, we have already calculated this number. So this is 300 minus 75, and this equals to 225. And last think is just calculate how many integers on that interval are divisible by 3. So are divisible by 3 and 4, and we have already calculated those. Is just n, 3 and 4, and that was equals to 75.